All right, it's a new day, and I think it's time for some more videos here. Um, let's see here what we got. We got a lot going on. First off, these videos are more about me learning and discovering things about C++ because I am really trying to understand all this so I can start getting into actually writing programs for myself. Whether they're for myself or to share with other people, either way. Um, but yeah, if you end up watching these videos and you learn something great, if you end up having any questions and stuff, I might be able to help. More than likely, I'll be able to point you in a direction of a source to use because I'm not extremely experienced with writing code or C++. I'm more of a beginner myself, and I'm just kind of sharing my journey of what I am discovering and learning with everybody else. So, let's pick up where we left off last time. Um, First off, on the right side, we have W3 Schools. Which is one of the sources I'm using to discover and learn. On the left side, we have VS Code, which is what I use to practice, write, and try to understand what's going on with the code as I write it. And I believe we are currently in class, learning about classes for C++. We started with OOP, which is object-oriented programming, and then got into what classes are and objects for classes, methods for classes, so forth and so on. Discovered that methods are kind of like a function. Um, for the most part, they are a function, but there is a few key differences. Methods are, it looks like, are only used with class, but can operate the same way as a function does. Whereas you can call it to get data. I know that I had set a challenge for myself in one of the videos that I made, and then come to realize a video or two later and stuff that I had uh, actually already accomplished that with the same example that they had in the next video I did using method instead of functions, where I was going to try to write a function and stuff that would do get rid of some of the redundancy of the code that was used as an example. So something I had learned there. Anyways, we left off, I believe, with C++ constructor overloading, because we were still learning about constructors. I think this is the last part of constructors, and then we're going to move on to access specifiers, which we know a little bit about in the code, VS Code over here on the left. We have public, which is we know as a access specifier. That's pretty much all we know about it so far. So let's dive into this and see what we can discover and learn today. So constructor overloading. In C++, you can have more than one constructor in the same class. This is called constructor overloading. I assume that kind of is the same thing as functions. Functions, you can have multiple functions of the same type with the same name. Um, and what you do is you change something about it to where it's the same but yet different. To where it may have multiple parameters in it for one and different amount of parameters in it for another, or it can end up having the same name but a different type, sort of thing, if I'm not mistaken. So each constructor must have a different number or type of parameters, which is exactly the same way a function works. You have to have either a different number or type of parameter in the function for function overloading. So the compiler knows which one to use when creating an object. Uh, why use constructor overloading? Well, since constructors are probably pretty close to the same as a function, it gives you the ability to create multiple objects for the same kind of a function, or multiple arguments for the same kind of function, and be able to use pretty much the same function name and just declare different arguments for two different functions that have the same name to it. So But here it has some points right here. Why use constructor overloading? To give flexibility when creating objects, to set default or custom values. So you can also set default like you can with functions. To reduce repetitive code. I think that's what constructors are meant for in the first place, or functions, to reduce repetitive code, which is something we learned about in a couple videos ago, which was the word dry. Don't repeat yourself, which is what that meant. We have an example here with two constructors. This class has two constructors, which with one without parameters and one with parameters. It looks like it's going to be based off of pretty well the same example we have here with a few modifications. So we still have class, we have car, we have public, we have two strings, one model, one brand. It looks like it gets rid of the year, so we don't need the year in there. It looks like it has two constructors in it, one without, and it doesn't have the actual declaration. It looks like it has the declaration slash definition instead of having a definition below it. So we can go and get rid of all this and this declaration right here and create two constructors inside this class here. So let's get this example written down here. Car with no parameters, curly brackets, brand is going to be set to, so we have the string brand up there, and we're going to set brand to unknown as a string. Yep, because it is a string. And then we're going to set model to unknown as well. And then we're going to create a second constructor, same name, car. In this case, though, we're going to have two parameters. So that's what the different numbers are going to be. One's going to be without parameters, the other one's going to be with parameters, but the two functions are going to be the same, which is overloading the same function with the ability to have different arguments, amount of arguments in the call. So we got standard string B and standard string M, B for brand, M for model. Curly brackets, and then brand is going to be set to B, and model is going to be set to M for our variables in the parameters set as both strings. Let's get down here to the main. So just looking at this right here, I am noticing something. Normally when we created a function, or even if you're creating a constructor, you can set a default as unknown for the two of them. And it looks like one constructor, if it doesn't have an argument, the default is going to be unknown as well for brand and model. Where if you know what the brand and model is, you can put those in as the arguments and have it print out what the brand and model is. So one looks like a default constructor, the other one looks like a argument constructor. So let's get down here to the main and get this example put in. We're going to go ahead and clear out all this code right here. Class car, car1, declared car class, car2, and we're going to set that one to BMW. Oops, not end. And X5. Create another one here, car3. Give it arguments Ford and Mustang. And then we're going to output all three of them. So standard output car 1. And for some reason I always forget to do this. I don't know why. I don't know how many times I forget to do that. No. Car 1 is car 1 dot brand with a space. Now I'm going to go to the next line here, so I'm not running off the page. And car 1 dot model, and then a new line. And then standard output for the second car 2. Car 2 dot brand with a space. Again, going to the next line there. Car 2 dot model, and a new line. Standard output for car 3 car 3 dot brand car 3 dot model, and another new line, just in case we want to add more later. Okay, so from what it looks like, yep, okay, let's go ahead and save it real quick. From what it looks like, so the first car is going to end up with the unknown. We're just going to call it, and then we're going to do output the call here. So we're going to have car 1 with unknown and unknown for both, because we don't have any arguments. So it's going to call this constructor right here. The next two cars, car 2 and car 3, are not going to call the default constructor. It's going to actually have arguments set. So we're going to end up with, in the output for 2, BMW and X5, and output 3, Ford and Mustang. In this case, we don't have a year, but yeah, if you wanted to add a year and stuff, you can add an integer year, declare it, and then have unknown there for the year, and then have another variable here for year as well, and setting up another parameter for that, and you would just add the years there. Or maybe you know what the first car is. Now, I still haven't gotten to the point where I can figure out how to get two things put in and still skip one. Maybe you have to create another function for that, which is probably the best likely bet. You would have to overload with another function, having a different set of parameters, because you know, say that it's a Toyota and you know what year it is, but you don't know what the model is, or you know that it's a Corolla, but you don't know what the brand is, sort of thing. So having more than just two constructors and stuff, filling in what you do know, and having unknown set for what you don't know, sort of thing. I'm sure you can write that out with many different cars if you wanted to, but in this case, yes, we should get car 1 with unknown, unknown, car 2 with BMW X5, and car 3 with Ford and Mustang as our output in the terminal. And yes, that's what we have here. And that is the expected result that they have here as well. So we know that we wrote the code properly, we don't have any mistakes, and we got the expected output that we should get. All right. Constructor overloading lets you create objects with custom values, just like in functions. You can have default or custom values, either one. So It does seem like I am getting more familiar with this and stuff because I'm actually able to recall how functions work, and knowing how function works a little bit better a second or third time around going through this material helps me also understand constructors. So that looks like it's it for constructors. It looks like we're going to jump into access specifiers, and it looks like we have plenty of time for that. This section is not too long, so let's go ahead and get started on C++ access specifiers, which would be telling us a little bit more about this right here, because we know that that is a access specifier based on notes that it left for us in previous examples. So access specifiers control how members, like attributes and methods of a class, can be accessed. They help protect data and organize code so that only the right parts can be seen or changed. Using access specifier, the public keyword is access specifier. So the public keyword right there is an access specifier. In the example below, the members are public, which means that they can be accessed and modified from outside the code. So we have an example right here, which is pretty much the same thing as what we have up here. Class with a name, public, this right here be the class, this would be the specifier, and these will be the members of that can be accessed from anywhere. Um, so it's pretty much just the example is just this right here, and with notes in it and stuff to indicate what each part is. However, what if we want members to be private and hidden from the outside world? In C++, there are three access specifiers: the public, the private, and the protected. Okay, so I'm going to mark that down here below in some comments. So we have public, which is members are accessible from outside the class. We have private, which are members that, I think they forgot that word, that cannot be accessed or viewed from outside the class. And then we have protected. So it looks like there is three different types of access specifiers. And these protected ones, I didn't even fully spell it. There we go. These protected members cannot be accessed from outside the class. My spelling is just getting worse every day. My typing ability is. However, they can be accessed in inherited classes. Okay, so three different access specifiers: public, private, and protected. The public can be accessible from outside the class. So anything outside the class that we've been doing right here. So all three of these can be can access any of this stuff that's in the public area. Now, if we were to set that to private, those members can not be accessed or viewed from outside the class. So you might be thinking, well, then what do we do with them if they're, I mean, this right here will accessing all this stuff, but if it's private, then why is it even in there? I mean, what can we do with it if we can't access it? I'm sure we'll get to that here in a little bit with some examples. Protected members cannot be accessed from outside the class. However, they can be accessed in inherited classes. Okay, so a little bit of a confusion there on that part. I'm sure we'll get to understanding that a little bit better. Let's keep moving forward so we can try to understand that. So private. Members declared as private cannot be accessed from outside the class. In the following example, we demonstrate the difference between public and private members. So we got an example right here. So it looks like we're going to have to clean up a little bit of this code right here. We'll start with the main, get rid of that. It looks like we're going to get rid of all this code right here. We're going to keep public. We're going to also change the class name here to my class. We're going to have integer x for the public. We have some notes here. There's some comments here. Public access specifier. And then we have public attribute. And then we have a private access specifier. We have a note here for a comment here for this private. Yeah, just same thing as I just said. And then we have an integer y being declared in the private as a comment of private attribute. All right. Now here down in the main, it looks like we are going to create an object for our class called myObject. And then we're going to use the object to give x a value 25. There's a comment here after that. It says allowed because it's public. And then we're going to create another object here for the class y and give it the value of 50. But with the comment right here, this is saying this is not allowed. So it looks like you will get an error doing this. But again, the question still remains, why are you setting something to private if you can't access it? Now, apparently we haven't gotten to that point yet. But it does say if you try to access a private member, you're going to get an error. So if we run this code the way it is, save it and try to run it, we're going to get an error. And there's the error, which is noted right there in the results. Okay, so looks like we got a note here in the yellow and a tip as well. The note, if it is possible to access private members of a class using a public method inside the same class. See the next chapter, so we haven't gotten to that chapter yet. So once we get there, maybe we'll figure out what we can do with private, since right now we can't do anything with it that we know of. We haven't discovered anything for that yet. We got a tip here. It is considered good practice to declare your class attributes as private as often as you can. This will reduce the possibility of yourself or others to mess up the code. This is also the main ingredient of the encapsulation. I hope I'm pronouncing that right. Concept, which is something we talk about in the next chapter. It's actually labeled encapsulation, if I'm saying that correctly. There's another note down here. Note, by default, all members of a class are private if you don't specify an access specifier. So if we don't have private, public, or protected, by default, we start putting members in there. All those members become private by default. For example, if we take out uh, these notes right here, in fact, take out the private right there as well, take out this comment right here, and take out the public right here. Bring that up one, bring that up one, and now by default, X and Y are both private and cannot be accessed because by default this class is set to private automatically. So if we try to run the code like this, we will get another error like that because we can't set anything to them. We can't access them. We can't do anything with them. Now to discuss public, or not public, but protected. Members declared as protected cannot be accessed from outside the class, but they can be accessed in child classes. And that's a new word right here that we haven't learned about. Child classes. What is that? You will learn more about that in Heritage chapter later on. So real life example. It has a real life example. Public, like the front door of your house, which is public, so everybody can get to one side of it, but they can't get to the other side of it. But they can get to the front door. Um, I'm not going to say what else is right here. So it says public, like the front door of your house. Anyone can come in. I'm not going to agree with that and stuff because that's not true. If you're not home and you got the front door locked and stuff, then no, not anybody can come in. But anybody can access the front door doesn't mean they can come in. Let's say it's more like so your front door, anybody can get to it, but nobody can do anything with it. Let's say it's more like your yard or your house. No, not even that. More like just your property, your yard. Roads, those are public. Anybody can access most roads. But private, look more like your locked drawers. Only the owner or trusted family, trusted friends can open it. I'm going to say it is more like your front door. So it's more of a private thing and stuff. To me, private means more like something you want to keep from everybody else except for your closest relatives, sort of thing. If you have a safe and stuff and it has money in it or deeds in it or things that you don't want anybody stealing, you even maybe have it bolted down to the ground in your house or whatever, or a safe in a bank or whatnot and stuff, it's only accessible by trusted employees or trusted members. Nobody can access it. Um, but private is normally stuff that you keep directly to yourself. Uh, in this case and stuff, private is going to be something that can only be accessed by trusted family members or trusted employees. Protected is a little bit different. So protected would be, in my opinion, what they have here is like a uh, family-only room. Children subclasses can enter, others cannot. I'm going to say protected is more like a business that has a front door with a key lock pad. Um, and you either have the code to get into the building or you have a swipe card or something like that and stuff to get you into the building. It's protected, but everybody has access if they have the card or if somebody lets them in for some reason or another. It's not exactly private. So I don't really like the way that they're describing those three words right there, but I mean, public roads, public transportation, private car, private house, um, private safe, stuff that you don't want anyone else to access except for people you know, and then protected, which would be more like a protected business, insurance. I'm not even going to say insurance, but yeah. So let's move on to the next thing. So we kind of have an understanding of what protected, private, and public are. as far as these things are concerned. We just don't know how to use them yet. With our code, we haven't discovered that yet, which we're moving on to now. Encapsulation, if I'm saying that right. The meaning of encapsulation is to make sure that sensitive data is hidden from users. Uh, to achieve this, you must declare class variables attributes as private, cannot be accessed from outside the class. If you want others to read or modify the value of private members, you can provide public get and set methods. So it looks like we're going to learn a couple new words, get and set methods. Real life example, think of an employee's salary. The salary is private. The employees cannot change it directly. So it is set by, in probably a computer or whatnot, it is set directly by probably the owner or the manager, either through an email or corporation or whatnot, sort of thing. Only the manager can update it or share it when appropriate. Encapsulation works the same way. The data is hidden and only trusted methods can access or modify it. Access private members. To access private attributes, use public get and set methods. Okay, so we have an example here. So let's see here. It looks like we're going to, let's go ahead and clear out all those comment here. Let's clear out the main. So we got an example that we're going to run, so we just might as well start with some fresh space for all this. Okay, so we're going to start off by renaming our class to employee. Oops. We're going to set it to private as suggested. Oops. We got a little comment here which says private attribute. And then that attribute is going to be declaration of an integer, which is going to be salary, the variable salary. And then we're going to have a public access. And this is, we have a comment here saying setter. It's going to be void type set salary with an integer s for salary. So this kind of looks like a constructor. Pretty sure it is. Salary will be set to s. Okay. Let's keep going. We got a little bit more to go here for the example. We have a setter and then a getter. Oops. This one's going to be the getter. And it's going to be a type integer get salary. No parameters set for this, what looks like a constructor. Return salary. And then we're going to move down here to the main. And we're going to create an object for employee. It's going to be my object, named my object. And then my object, we're going to use that, access the class using the object, get salary as the constructor with a parameter of 50,000 for the value, and then we're going to output the object get salary. All right. Okay, so we got a little bit of an issue right here. It doesn't like this right here. What am I missing there? Let's see, too many arguments in function. Ah, I misspelled. It's not get salary, it's set salary. There we go. All right, so let's take a look at this code and see if we can't decipher it before we run it and to see what our result is. So first off, we got a private here. Private access specifier. So this right here is going to be set and nothing else can access this. Except for, according to our notes that we had from previous thing, and I didn't keep them. Good job. I didn't keep them. Let's go back and look at it real quick. So, private, right here, according to this, members can only be accessed or viewed from cannot be accessed or viewed from outside the class. So, we've got a private section here that can only be accessed and used inside this class, which is how we're able to have this right here. So we're having one constructor with a parameter set salary, which is accessing this integer from within the class and setting its value to s. And then we have another constructor here, almost identical, but not quite. I don't think it's overloaded at all. We got two different names, two different types, and no parameter for this, so it seems to be completely different, so there's no overloading here at all. This one here is just going to return salary. So we have here in the main, we are declaring, we are calling we're creating an object for employee, which is also calling in some cases. My head's just not in the game today for some reason. And I'm not sure why. Maybe I didn't get enough sleep last night because my brain is not working. The gears are just not turning. Okay, so we're going to create an object right here. We're going to call that object dot set salary. So we're going to create a argument right here, which is going to be passed into the variable up here for the parameter, and it's going to set salary to 50,000. So now this is going to be set to 50,000. Okay, we're not doing anything else but that right there. So now salary has a value of 50,000. And the next line though, we are outputting the object get salary. So we are using another function or another constructor inside the class to return what salary actually is. So we're using one to set the value, and we're using another within the class to output the value, even though we got the value right here. So this one's creating the object, this one is setting a value for salary, and this one is outputting that value. So in this case right here, even though yes, it's not accessible from anything outside, so we have to use things inside the class in order to access this, adjust it, we're creating a value for it, and then we're going to output whatever this is right here. So we have a public section right here to access the private section. And that public section is giving us the ability to output it and give it a value. Now, why have this set in private? Because we don't want to change the fact that salary is an actual integer. This declaration right here is set and nobody can change it. Nobody can add anything else to it, change it, whatnot. If you were to get in here and stuff and be able to change this, even though we've done it out here, to a default value of 100,000, then that would potentially change this down here. But so in the output right now, we should be printing out 50,000. Let's go ahead and save it real quick, run it, and it's set to 50,000. Now, if we go ahead and actually set this to something, say 10,000, control save, run it, we still get 50,000 because we're changing it from within here. So we can have a default value right there of 10,000. So if an employee starts and stuff right off the bat, they get their name put into the system and everything, they're going to start getting 10,000 as a salary um, to start off with until we go in there and change it. So we have we can end up setting up different employees, changing each employee's salary, setting it down here, and in that way everybody has access to see what it is through the main, through the data from the main, but they can't change it, they can't adjust it, they can't do anything else. That has to be done from within, which therefore, if you were to have the right clearance, you can get in here and change it, but if you don't have the right clearance, then you can't change it. That's kind of how I see that. So if you're on a computer and stuff, you have administrative access and stuff, then you might be able to get in there and change it. But if you don't have administrative access, then all you can do is view it and see it. Either way, you're probably going to create problems without trusted people. Sorry. Okay. Going to the next thing, encapsulation. Well, what we already done. Yeah, moving on to the next thing. So down below the example is kind of explaining. Example explains. Salary is a private, cannot be accessed directly. So we cannot access it down here, which if it was public, we can access it down here directly, we could. More running through this, seeing examples of this, because of what my problem was just a little bit ago was, like I said, the gears weren't turning in my head. I wasn't seeing things properly. And pretty much with this right here, I kind of still have a puzzle in my head, and the puzzle's just not coming together just yet. I understand all this, but the pieces are coming together slowly. They're not coming together as fast as what I'd like them to. The rest of it explains, so set salary sets the value of the salary. Get salary returns the value of the salary once it's set. If you switch these and stuff, then yes, you won't have to, you will end up with the default. So if we comment this out right here, save it, run it, we're going to end up with a default of 10,000. Or nothing in case if we didn't have anything set for there at all. Okay, we use myObject.setSalary to set 50,000 to assign a value, and myObject.getSalary to print. So yes, I just simply need to do more exercises like this and stuff so it can sink in deeper. I think that would help with getting things going in my head a little bit better. Why encapsulation? It is considered good practice to declare your class attributes as private as often as you can. Encapsulation ensures better control of your data because you or others can change one part of the code without affecting other parts, increasing security of data. So having it set to private and stuff means that it's secure. Getting the password and stuff to access the private to administrative properties or whatnot means your data is no longer secure and things need to be changed at the company most likely. So that's the end of encapsulation. Again, I'm not sure if I'm pronouncing that right, but I think we're going to go ahead and end our video right there, and we will pick up with the friend keyword. So again, if I've said anything wrong, I know I'm getting a slow start today. It's kind of late already as it is for making videos, but I'm going to still try to make my videos. They're not extremely exciting, but learning really isn't. Not until you get to where you're actually creating some interesting things. And right now, I'm not creating interesting things. That you're just more kind of watching me learn to discover this stuff. Maybe get a laugh out of it if possible. I really don't care. But yeah, if there's anything I've said that's wrong, feel free to correct me in the comments. If you got any questions or comments, leave them in the comments. I think that'll be it for this video, and like I said, we'll pick up at C++, the keyword, the friend keyword, in our next video. We'll see you then.